Welcome to Wastewater Monitoring Analytics Module 1, Wastewater Treatment Plant Trend. I'm Rebecca Schneider, an analyst in the Data Science Division at the Houston Health Department, and I'm presenting on behalf of the Houston Wastewater Epidemiology's analysis team. This video is preceded by Module 0, Data Preparation, so see that video for more information on steps before a wastewater treatment plant trend. In this module, we will cover the listed topics: individual trend assessment via spline, aggregation to obtain city trend, normalization to a fixed date, relative one-week change, and then comment on the algorithm to identify trends. First topic is individual trend assessment via spline. We transform the copies per day to the log 10 copies per day and fit a natural spline. More details on the specifics is found on our GitHub. That will have practice R code. When you first fit the spline, you will need to adjust the degrees of freedom via cross-validation, minimizing the mean squared error of the fit. And visually inspect the fit, see if the fit is capturing the peaks correctly and that the end of the spline is representative. Then, going forward, check this fit each week. As mentioned, each week we check the performance of the spline and do a sensitivity check on the degrees of freedom. Here's an example of a weekly plot in which we are comparing degrees of freedom 27, the green line, to degrees of freedom 25, the black line. Almeida Sims, the plot on the left, shows very little change due to degrees of freedom. But for North Belt, the plot on the right, degrees of freedom 27 better resolves the Omicron spike we had in January 2022. Next topic is aggregating to a city trend. Starting with the plot on the right, we have date on the x-axis and log 10 copies per day on the y-axis. The faint gray lines are splines for each of our 39 wastewater treatment plants. The green line at the top is the result of our citywide aggregated total, and the gray shaded region around it is the 95% confidence interval. The steps on arriving at this city trend are described below. For the trend, reverse the log 10 transformation, compute the sum across all the wastewater treatment plants, then apply the log 10 transformation to the sum for plotting purposes. The approximate standard error of the city trend on the log 10 scale is as follows. Sum the variance of each wastewater treatment plant spline, then take the square root of the variances. The approximate standard error is computed using the simplest steps. If we added the covariance over time between the wastewater treatment plants, the variance would most likely increase, meaning the method here is a conservative estimate of the uncertainty. Next topic is normalization by an anchor date. In Houston, we communicate the viral load information as a percentage of our anchor or benchmark date, July 6, 2020. This has worked for Houston as a way to convey information. Reporting just the estimated copies per day was hard to digest, so along with copies per day, we include this percentage of the benchmark. We chose July 6, 2020, as it was the first big peak in Houston. It was understood as a time when the city was experiencing high COVID burden. When we calculate the percent of the benchmark levels, we are not using the log 10 values. We remove the log 10 transformation and then calculate the percentage. We will cover an example on the next slide. We then convey this information, percentage of benchmark levels, in a heat map. The example listed gives a simple calculation, and again note the viral load levels, the copies per day, are not on the log 10 scale. We then look at the relative one-week change. It takes the difference between this week's estimate of copies per day and last week's estimate of copies per day. We will also cover an example on the next slide. This information of relative percent change is then shown in a heat map. In this example, we see that the percent change is calculated with the log 10 values. These could also be calculated with the log 10 transformation removed. Next, let's briefly touch on detecting trend. First, we classify the trend at a wastewater treatment plant as increasing, no trend, or decreasing. We began the process by manually inspecting the trend. Since then, we have started to develop an algorithm that will be covered in more detail in Level 2 training. Thank you for watching this Module 1 video. If you're interested in learning more about sampling, analyzing, and integrating wastewater data into public health interventions, Check out our other training videos on our website. Support for this program was provided through a grant by the CDC. The Houston Wastewater Epidemiology team would like to thank you for viewing this training video.